Well, hi everybody, and it's time to get back onto this preamplifier, which I was looking at back in the summer a couple of months ago. And this is a very challenging unit to work on. I've got no schematic for it, and it's gone through a pretty extensive modification too. Even if I had the schematic, it might not even match all the modifications that were made in factory-made modifications. The unit was returned to the place where it was built, and these modifications were made to it. So the problem with this guy is you had a few component failures, and a couple of diodes. I have the diodes here, and then I've had a very hard time finding a replacement for this, and I think mostly it's because I don't normally buy these kinds of parts. So I ended up ordering the replacement from Taiwan. Here it is. We're going to open it up and just see if I got what I really think I ordered. And if so, then we're going to go ahead and try and fix this radio up, or this preamp up. Where's my knife? Okay, my knife is taking a walk, so we'll use this. It's like Christmas, eh? That's a little advertisement. Backing slip. There we are. Show me they're the same. TL783C, TL783C. Okay, they're all TL783C, and that's a TL783C. It has a symbol on it that looks like Texas Instruments symbol, but you know, it doesn't look right. Interesting. Anyway, I got them. I got 5 of them, so we can afford to blow a few up. Excellent, excellent, excellent. So we're gonna replace that, put this back on the board. I think I've already done the diodes. Yeah, there they are. And then we have this really strange challenge of trying to guess the value of a missing resistor. And so I'll have to reason our way through that. But this should be pretty straightforward. Out of here. Let me just put a little tape over the end of it here. There we are. Okay, let's see if we can mount this guy back on here. Some hot glue in there, I believe. There we go. Okay, that's pretty good, just like that. Okay, we'll have this guy tested out pretty soon. Now, there's a big risk here, of course. I don't really know what caused these things to blow. 2 diodes and that thing. It could be one of those 3 parts, took the other 2 with it, and I've replaced all 3, we're good to go. Or another possibility is there's another failure that took these parts out of the picture. And that includes a resistor, the one I mentioned earlier, which burned right up. And that's why I don't know the value of it. It was so burned up, there was no way to know. Oh, there's my solder. So there are certainly lots more challenges coming here. Let's take a good close look at that. Now there might be a soldered bridge in there. I don't like the way it looked. Yeah, I think there is. It's really close. Yeah, it reads a dead 0. So I think there's a short there. That's not the easiest thing to clear away. Did it. Right down to 0. Huh. So often it is the easy stuff. Just a whopping bridge in there. And I just wash it right out with a soldering iron. I think I may have. Looks better. That looks better. Seems to have gotten it there. Okay, it's no longer shorted. Okay. Now, one of the problems with this set was somebody soldered in a capacitor and left the tails on like this, sticking out, and they grounded against the chassis, and that may have been the whole cause of this whole problem. So I'll bend mine back a little bit. And we're pretty much ready to test this thing out. Pretty much. Gotta remember how to hook up all the wires. It's been a long time. Just tack these wires on quickly. That's all they really require anyway. I hate that smell of burning plastic. And yes, I did take more photos. Here's the photo here of it, and I can see the how the wires are connected here. So this one is oh man. Okay. I can tell which of these two colors, a purple and a gray, which one goes which way. What I can't tell so clearly is which one of these goes where. I tried to leave these bent in a position where they're, where they're going is kind of obvious, but this has been sitting around for quite a few months. It's been moved a few times, but I'm pretty sure that's how it goes, right like that. Right like that. Okay, so let's solder up. It's gray one in both cases towards the back. Got a little warm. I don't normally work on anything with my soldering iron in my hand like that. Kind of a rule with me to avoid that. So although this amp has tubes in it, it's not that old. This is from mid-90s, when tubes were returning to popularity. Ooh, that's gonna get hot. Hot, 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 hot. Now I think that's all the wires that need to be connected. Oh, no, dumb of me. I forgot about the resistor. Phooey. Phooey. I'll have to take the board up again. So here's the problem. So you see the string of resistors coming down here. You can see there's one missing. I've removed it. It was burned to smithereens. So I removed it. I was kind of hoping all of these would be the same value, but they're not. They range quite, there's quite a variation in their value. And they look like they were arranged pairs in series. You know, here's a pair and a wire, and here's a pair and a wire. Maybe, you know what, maybe this and this is the same as this and this. If that's so, then this is the same size as the missing one. That might be the case. So let's get out the ohm meter and see what we can see here. Compare these. What's here? So this guy. So that's a 270K, and its brother, interesting. Yeah, these are identical. 27. Did I say 270K? Where did I get that from? 27K. 27K. Zero. It's a little unexpected. That's the third. Okay, so there we are. So that's a 260 ohm. 270 ohm. Resistor. There doesn't seem to be any pattern between the three of them. Now, let's see if I can actually read those values off. I'll use the camera here and see if I can spot it. 27K, 27K. You can certainly read that. And this last one here. So I can see the 27 on this and the 27 on that. This guy here. What's that say? I think it says 270 ohms. Which is what we're reading. We're reading 270 ohms. So if we use the pattern, this is like a resistance split in two between two resistors, probably to increase heat dissipation or improve heat dissipation. Same thing for these. So if that's a 270 ohm resistor, I need another 270 ohm resistor. That's my guess. I think that's about as good as it's going to get. So let me get one. Oops. Now luckily I have some high wattage resistors here. So I just have to find the 270K one. Okay, so it looks like the closest I'm going to get here is 250 ohm, which is pretty close to 270, isn't it? $250 ohms. So we're going to stick one of these in there. We'll have to cross our fingers a little bit. 250 ohm. This is 260, I think. Let's check this out. And apparently I have to unload the clothes dryer after that. 250. Okay. Excuse me. Okay. Now, I don't want these to short. Leave them long again, but bend them over. Okay. This little wire came off. Well, I think it's ready for testing. But I think I'll unload the log. Okay, well I think we're ready to test this. And, how exactly do you test this? Let's see, there's a couple of relays in it. Protection relays. I'm going to guess that those would snap in a few seconds after we apply power. Which would be a good sign. Another one is no smoke, flames, no blown fuse. I'll put it on current restriction. We can keep our eyes on the light bulb back here. Quite a few capacitors in here, so there's a bit of a charge up, no doubt. But after that, we shouldn't see much on that light. Temperature of this. Let's get ready to measure the temperature here. Get my temperature gun ready. And let's see, smoke coming out of this resistor would tell me that whatever was wrong before is still wrong. Why don't we just do this for fun here? Because I just love doing tests. Put this right around to the tone. Let's see if there's a ground on this thing here. Well, there's no grounds, no hard grounds in there. What about shorted capacitors? Ooh. That's interesting. I got one thing making sound. Two of them. Three of them. This might be a pretty bogus way to test things, though. Yeah, I'm not gonna... if only one of these rang out, I might be excited, but or if they rang on both sides, that's like that one. That's kind of weird. That capacitor is does not appear to be associated with the area that burned up. It says it's a 25,000 8-volt non-polar capacitor, 25,000 microfarad. 2,500 microfarad. It's a big whopping capacitor. And it's displaying a short, or is it? Well, let's pop it up. Let's pop up one lead and see before we apply power. That would be the prudent thing to do. Okay. And it should be pretty easy to pop it out. Oh, it's glued. Okay, we'll have to pull up on the wire because the whole part is glued down. Okay, so I'll cleverly grab this in a way that it's applying tension to the lead. It should just... very clever indeed. Fallout. There we go. And it wasn't glued very good either, was it? So there it is, airborne. Ground on either side of this. Let's check it. I give it a 2% chance of having a short. Yeah, there's no short on that. Okay, now. Why is it not popping through? More solder on that. This is not a good way to solder things. It's not taking it all. Fooey. Fooey on Yui. It's another case of needing two hands. Yeah, push the lead through enough I can get a piece of it here and bend it over, lock it down. No way. see if we can solder like that. Okay, that got it. Pretty curious why there's a ground on there, though. Let's check that again. And it doesn't, doesn't make a lot of sense to me. What happened? Don't read a ground on either side now. Don't read a ground anywhere. What happened? Well, I don't know what happened there. I didn't have the board up on its plastic standoffs. Maybe there was a short under the board somewhere. So that's a good warning right there. Make sure this is up on its stands. Let's reattach the ground here. So I think we're left to try it. Oh, these wires popped off here. Yeah, I think we can only try it from here. So we're gonna put in our plug. And, power switch is off. Let's get my voltmeter ready here. Okay. Everything is ready. I'm nervous, as always. Volumes are down. Power switch is off. Okay, we're applying power to it now, but I haven't turned it on yet. About 20 degrees. There we go. Okay, I turned it on, I turned it off quickly. Did not light up my light bulb at all. See if anything got warm during that affair. These guys got warm. These ones got warm. This is ice cold. So is that other one. So these two saw no current as far as I can tell. How about these guys here? Nothing bad happened. Let's turn it on and wait and see if we hear a click. Here we go. Also looking for smoke, discoloration. Well, I certainly heard no click. Two heaters are on. Checking a few temperatures. This guy's getting warm. Not ridiculously hot. Well, for all I know, this is working, so I think we need to test it now. So I'm going to have to set up inputs and outputs on it. Switch off. Power off. Okay, give me a minute, I'll set up for the next actual. Okay, I think we're just about ready. My signal source will be this radio, and the output from the preamp will be fed into my signal tracer, and we should be able to hear it at that point. So first we're going to check and make sure. Yes, that's the radio.
Earlier this week I was open.
Okay. So I know we got a radio signal there. We should be able to pick it up right here.
I updated the package.
There it is.
Of girls playing in the leaves and planting trees. Two girls.
We should not get it on the output until we turn this thing on. Okay, we all set? Yes, we are. Switch on. Wait a minute. Don't switch on. Wait 1 second. Let's just do another little safety thing here, considering what happened with the record player. It gave me a couple of shocks. Switch is off on the unit. Power supply's on. Touching the ground point. We see 10 volts AC. That's not a problem. That's what I would have liked to have seen on that record player instead of 117. Which incidentally, I corrected that problem on the record player by lifting the grounding capacitor, which didn't seem to be serving any useful purpose anyway. Okay, so that guy connects there to ground. More or less, there he is. Ready on here. Ready on here. Okay, here we go. Switch on, volume's down. Switch on. Charge back up. Okay, it's charged up. Input, output. Volume up, volume down. Volume up, volume down. Okay, we didn't hear anything on the output. Didn't hear any relay snap. Didn't hear anything good happen with it here. Isn't this disappointing? Hey, what about these switches here? Yeah, it's set to phono. Set it to auxiliary. That'd make more sense.
Most of the technologies through which people are producing selfies are already hooked into networks.
Now, let's see, there's a mute play button. Oh! Oh. Let's just watch out now.
Are you?
Okay. Let's check this.
From her Instagram feed, we are saturated by images. Begin to build up
Bingo.
image in terms of how that self is represented in photography. In this way, it allows people to kind of experiment with controlling how their image is placed. I mean, you may have had the
Hey, success has been had after getting all the switches right. I should have looked at the front panel switches. There's a mute and a play, and it was on mute. There's a tape and a source, and it was on tape. And there's a phono and an auxiliary, and it was on phono. All of them were wrong. So now it's set to play, source, auxiliary, and bingo, we have output. Let's try the other channel.
In terms of how people present themselves.
We have access to a lot of sophisticated tools, right? We have great cameras attached to our phones now, but
How do you
most
like
people
that?
are not trained as photographers.
Excellent. So we're going to leave that running. I'm going to clip lead it here.
Right, they get skinny arms that way, and men will kind of look very to make their biceps look bigger. And everyone looks like posing that
Ooh,
we're learning
careful,
from
that
fashion
board's still
photography
loose.
and fitness photography. And then the duck actually
Controls need a little cleaning.
right where your lips are sticking out. It's all the MySpace era. I have no idea what that's about.
It should be fairly easy to do.
Angelina Jolie look, right? Those are kind of frowned on now. This is sort of really cliched, immature, naive teenage girl mode of expression where you're trying to adopt a kind of sexiness that looks really forced now. So I guess what people are doing instead of that now is they're sucking on straws. They're drinking things which allows them to make the duck face. But there's a pretext for it. I guess people really like that look. Their cheekbones look prominent and that much.
Duck-faced.
Yeah, exactly.
There are selfies at funerals that show tumblers of really inappropriate selfies.
Yeah.
First of all, why do people do that? And just what is going on with taking a selfie of yourself at somebody's funeral?
One of the main ways that we engage with others online is through the reproduction of our own image, right? So everybody in my Facebook feed has already seen what the Eiffel Tower looks like. So if I go to Paris, they don't need me to take a picture of the Eiffel Tower and share that. But what makes that salient, interesting to my community is if I am in that image as well. Now, a picture of me doing duck face in front of people, because that's appealing to them.
Very good. So there we are. I just have to reassemble it. And we're done. Excellent. Okay, so here's a look at the reassembled preamp. There it is there. Two separate volume controls, one left, one right. I have no inputs or outputs connected to it right now. On the back. Some very nice looking inputs on the back. Nicely spaced out, not too crowded, beautifully labeled. Yeah, very nice, very clean.
watching.